Welcome. This is September 17th, 2024, and welcome to another segment of the Validated Patterns Special Interest Group on OpenShift Commons. Today we have Gaurav Mehta, who's going to be talking with us a little bit about deployment of a machine learning model using data science pipelines and how to set up these pipelines in OpenShift AI. Gaurav, if you'd like to say a few words, and I'll turn it all over to you.
Sure. Hi, my name is Gaurav Mida, and I am based out of Delhi, India. And my day-to-day activity involves creating solution pattern to basically show what a product can do for us. So basically, solution pattern describe what is possible, what we want you to know about our product. That is what solution pattern is. And now talking in terms of today's topic, here I'm going to present two things. First is Red Hat OpenShift AI, and then we'll talk about MLOps, how we can implement the MLOps solution using Red Hat OpenShift AI. So Red Hat OpenShift AI helps in building out an enterprise-grade AI and MLOps platform to create and deliver Gen AI and predictive models by providing the supported AI toolings on top of the Red Hat OpenShift. So Red Hat OpenShift is a trusted, comprehensive, and consistent application platform that can scale efficiently to basically handle all the workloads for the AI operations and models. Now coming to the MLOps part, so basically brief intro on MLOps before we go to the solution pattern and see the demo there. So by applying the DevOps and GitOps principles, organizations can automate and simplify the iterative process for integrating machine learning models into their software development processes and production rollouts, monitoring, retraining, and redeployment for basically having the continued prediction accuracy of the model. And in this solution pattern, we'll see how we deploy the model in Red Hat OpenShift AI, and then how using the Flask application, how we can consume the model from the REST API. So let me share my screen. So I'm in this website solutionpatterns.io, and right now I am on predict stock price trend using Red Hat OpenShift AI solution pattern. And what I'm going to discuss is first we'll go through the architecture diagram, what we are doing here, and then I'll go to the demo part. So in this solution pattern, there are two main components. First is the model part. Model, we basically download the data and then we develop the model, train the model, and then we store that model in Minio. Minio is a S3 storage based solution. And then we deploy that model into the Red Hat OpenShift AI. Once we deploy that model in the Red Hat OpenShift AI, from there we get one REST API URL, and we will use that URL as one of the environment variable in the application. And this application is a Flask-based application, which is residing in GitHub. And from GitHub, we will deploy the application in the OpenShift. And OpenShift will basically create the pod for that application, and that application will be accessible through a route. And once the application is accessible, we will do the inferencing using the UI. We'll basically do the inferencing, and then the model will basically generate the data, and that data will be displayed in the UI. So that's the architecture of this solution pattern. Red Hat OpenShift running. These are the operators which I've installed earlier so that we can save time and just directly go to the demo part. I have Red Hat OpenShift AI, OpenShift Serverless, OpenShift Service Mesh, and Auth It's a OAuth based operator. So these operators are being used in the current demo. And When I go back to the solution pattern, in the solution pattern, there's a workshop tab. In the workshop tab, I have listed all the detailed steps which I'm going to go through in our current demo. So right now, I have already completed the installing the environment part, and I'm going to go through the delivering the workshop part here. So here we are going to copy one repo, basically clone the repo, and from there we'll be running the customize to install a particular project and secrets which are required for the mini-IO and the mini-IO setup. So I'm going to go to the terminal now. There I'm going to run one file setup.sh which will create the required resources. So this is the project in Red Hat OpenShift AI. It's basically a way to organize the resources when working on the AI ML applications. And now it will install the MiniIO. MiniIO is a S3 based storage solution. So I'll see here. So MiniIO is getting installed, MiniIO API, MiniIO UI, and all these resources are there.
Yeah, so
And
Gaurav, as that's coming up, you could potentially just use any S3 bucket, Ceph, or like an S3 bucket on, let's say, like a pure FlashBlade or whatever you might have out there, correct?
yes, it has to be like S3 based storage, and then like we can use different providers as we like.
Mhm.
Sure. And this is done now, so I'll just go back to the workshop one. And now I'll go to the Red Hat OpenShift AI dashboard, and here we are going to the projects. So this is the project which I created, stock project, and in here we are going to create the pipeline server. So pipeline server, pipeline data science pipelines basically enable the automation of AI ML workflows. So whatever we can define in the Jupyter Lab notebooks, we can automate those Jupyter Lab notebooks through a workflow. And right now I'm going to configure the pipeline server. I'll just use the existing secret which I just created, and it's going to use the MiniIO S3 storage. And in MiniIO, I have one bucket pipeline artifacts where the all the artifacts related to a particular run will be stored. And I'll just keep everything as default and just click on configure the pipeline server.
So,
So we
Gaurav, real quick. So before you installed MinIO, did you already have OpenShift pipelines installed or Tectime already installed?
so I in this demo I'm using the 2.12 version of OpenShift AI, and it uses Argo workflow behind the scenes. So I'm not using the OpenShift pipelines right now.
Okay, awesome. So you're saying that the Red Hat OpenShift AI uses Argo workflows?
Right now, yes, the version which I'm using 2.12, it's using Argo workflows.
Okay, awesome.
Going back to the pattern. So we have completed these steps. And now once our pipeline server is up and running, then we'll create our workbench. So workbench is a containerized working environment that runs as a pod. It includes a collection of common AI/ML libraries and a Jupyter Lab server. And this workbench runs as a stateful, meaning that we can stop it or restart it without losing our work. So going back to the Red Hat OpenShift AI. So see, once we see import pipeline, it means that our pipeline server is configured. Now I'm going to go to the workbench. And here I'm going to create the workbench. And for the image, I'm using the standard data science. So for the Image is like we can have our own customized image, or we can use the standard already defined the images. We can define our own image with all the libraries which a data scientist will use.
And so
Uh,
a bunch of these projects are already standard in the OpenShift AI tool. Is that right?
yeah, yes. So there are like standard images which are available for CUDA, PyTorch, or TensorFlow,
Mhm.
and I'm using the standard data science. But let's say in a project there is a requirement where they want to use their own custom images, like they have some specific libraries which they want to use. So they can create the image and store it in Quay, and from there they can source that image in a particular workbench. Basically, they can control like what all libraries are being used in the environment.
Cool.
And here I'm going to use one of the secret. So I defined a configuration in MiniIO connection. So MiniIO connection, like the data connection is basically a set of configuration values that are used to store basically connect to the storage system. Here we are using MiniIO for our storage, and the data connection which I've defined here, I'm going to use it in the workbench so that our workbench can connect to the MiniIO directly. And I'm creating the workbench now. Since this is starting up, so I'll just open up the MiniIO UI part. So I have two routes. One is the API route and one is the UI route. So we are going to use the API route in our Elira pipeline. I'll show that in some time. And right now I'm just going to the UI part where we will be able to access the MiniIO console using the secret and password. So these are the buckets which I created from the CLI, which I earlier showed. And our model, when we run the pipeline, our model will be stored in this particular bucket models. So once the pipeline runs, the data will come here. And the pipeline artifacts, all the logs related to the pipeline will come here. Now, going back to the Red Hat OpenShift AI dashboard. Once this workbench is up and running, we are going to clone one repo. And in that repo, we have the this is the repo which I'm referring to. So in this repo, we have one notebook, create model. And in this notebook, what I'm doing is I'm creating one model using LSTM. First, we download the data from yahoofinance.com for a particular ticker. So ticker is basically Apple or Microsoft or any other. We can choose any ticker we want. Right now, I've configured this demo to work with Apple, IBM, or Microsoft ticker. So we'll use Apple this time. So we download the data from the Yahoo Finance. Then we make few changes to the data, and then we create a model and train that model with this data. And once the training is done, then it basically like stores the data in the MiniIO. Our model format is ONX, so we'll store the data in the ONX format, and that model will reside in the MiniIO URL which we have specified. So this is the notebook which I'm going to run as a pipeline from the Red Hat OpenShift AI. So my workbench has started, and I'm going to go into that workbench. It will open the Jupyter Lab, and from here we'll clone our repository. And I'm going to use Alira. It's a visual, like will create Alira pipeline using the visual editor. So I'm just going to click on this pipeline editor, and it opened up a visual editor. And from the stock text code, I'm basically going to drag and drop my notebook, which I just showed. So in a particular pipeline, we can have multiple steps. And right now, I just kept one step, but the pipeline can be divided into multiple, like 4 or 5 steps, depending upon the project. To keep it simple, I'm just using one particular step. And right now it shows that runtime image is required. So I'm going to open the properties and choose the Python 3.9. And there are some file dependencies. It basically installs a few of the Python libraries. So I'll just add this requirements.txt. This is the file which I added. And ticker, I'm going to use the Apple ticker and just save the pipeline. Before we run this pipeline, we have to make one change to the runtime. And this is the endpoint which we have to change. So we have to use the MiniIO API endpoint. Just save and close. And now I'm going to run the pipeline. So this job was submitted to the data science pipelines, and we can see the status of the run here. So it will open up the Red Hat OpenShift AI dashboard, and our pipeline will be shown here under experiments and runs. And this pipeline is running right now. So we'll see a lot of logs coming here. And if I go back to the mini app, here we will see that this is the run one, and we can see all the logs will show up here. We can basically go through the logs or download the logs if you want. And once the pipeline finishes, our model will be stored in this particular bucket. We'll just give few minutes to this run. See, like it's running. I'll just keep it running, and I'll go back to the solution pattern. So in the solution pattern, we have covered all this. We have edited the runtime. We have run the pipeline. Now, what we are going to do is we are going to deploy one Python-based application. It's a Flask UI, and we are going to OpenShift, and then from there we'll deploy this application. But before deploying this application, we need the model URL. So our pipeline has to finish, and it will basically generate one model file here. That's true. Any questions so far? So see, our model has been stored in this particular bucket, the models bucket, forecast.onx. And now I'm going to go and use the terminal to deploy this model. I am going to use the this customize. So I created two things, serving runtime and an inference service. And now I'm going to go to the dashboard to display the model. I am in my workbench and I'm going to the models in here. See, this is the model which I just deployed, and it takes like 1 or 2 minutes to come up. So right now the status is pending, and once the model is deployed, it will turn into green. And this is the URL which I was referring to earlier, that our UI application needs this URL. This is the inference endpoint to basically make the prediction. I'll just first let me just go to the OpenShift console and start the deployment of the application.
Yeah, while you're doing that, just to make mention there, I saw that you're using OpenVINO as part of your deployment there. And we've been doing a lot of work with Intel. In fact, looking at the validated pattern site, we have like eight patterns that were built with Intel. OpenVINO is a great tool and implemented along with OpenShift AI. It's really, when you don't have uh, really performant hardware like GPUs or Gaudi, Gaudi 2, Gaudi 3 specialized processors and things like that. Or even if you don't have like AMX accelerated Xeon processors, right? Think about it as if you're out at a edge site or something like that. OpenVINO gives you the ability to kind of like balance the type of hardware that you have with accuracy of the model deployment. So really cool tool.
Definitely, totally agree. So this is the environment variable which I'm creating model URL, and I'm putting the inference endpoint in here. See, the status is turned to green. So our model is up and running for the prediction. Check what is Python. So these are the resources which are created. Right now it's building the application. Once the application completes, we'll be able to basically generate the prediction like what will be the stock price trend for Apple ticker, as we used Apple in our run. And if you want to like check another stock like Microsoft, so we can basically change the value here, save the pipeline, and run the pipeline again. Then it will generate another model forecast to 2NX. And from when we deploy that particular model, then we'll be able to predict the stock price trend for Microsoft. See, like this will be the UI which will be available once the application finishes, and we select the ticker from there, and then we generate the forecast. And once the forecast is generated, then this graph will be displayed. So it will basically show that the stock price of a particular ticker will go down or up for next 30 days.
All right, Gaurav. So how accurate is this? Do I put my stock tickers in here?
So the machine learning algorithm is not accounting for like other different factors involved, like election or the inflation part. So
Well,
it
my,
trained
my
it.
advice to everybody out there is, if you really want to make some money in the stock market, just watch exactly what I do and do exactly the opposite.
So, so see, this is another cluster which I'm using for this. So this is another cluster, and the same application is deployed Flask. And here I use the Microsoft ticker. And if I click on generate the forecast, then it basically displays that this is the stock price trend for Microsoft. And this data is coming from another model which is basically running in another cluster. I'll check this out, but that concludes the demo. Any questions?
Yeah, I was just kind of thinking about like other types of predictive models that could be used, or things that I've seen coming out of like the capital markets risk analysis type thing, using Monte Carlo with probability distributions and things like that, and where we've run into potential areas where we might use a pattern in order to take that distribution, take the data from a stream or from a data store, and then move that out to whether it's a private cloud or a public cloud deployment, so that you can use some GPUs or some heavy hitting hardware for a short period of time in bursts, and then bringing it back. I know that we have, on the validated pattern side, we have like a fraud detection that's more of an anomaly detection type of process. But just a few thoughts. I was kind of like thinking, how could we use something like this, for other types of predictive analysis?
Sure, sure, sure. Okay.
Yeah, I don't know if anybody else has any comments. Like Dwayne, I know we were talking about some of the work you've been doing, mostly agriculture, right?
Yes. hmm And what's in my mind is, you have all these domain experts, and they have a certain way they like to been doing stuff forever. And how do I explain, get them out of their zone, Um, um,
This model, like when we have like sequential data, like the this model basically predicts the data on the basis of like past data. That's like how sequential model works. So anything where we have the use case of like we have the past data, now we want to predict the next 30 days or next 30 points. So there we can think of using this.
If there's no other comments, we could end early today. Yeah,
Thank you guys.
do appreciate looking through the way that you're using the pattern, and um,
Sure, definitely.
interesting use case there. You know, I wish I could predict stocks, but yeah, always looking for what options do we have out there for business use cases. Working a lot with, personally, I work a lot with the system integrator teams, as well as the ISV teams, the hardware teams as well, in the in the ecosystem team, right? And so,
Sure.
being able to um, understand what types of things that we could bring to bear and use in some of those scenarios is always helpful. All right.
Okay, guys. Thank you.
Appreciate it. Thank you.
Okay.
Have a great day.
Yep. Thank you.
Bye.